Welcome to this physics representation. So the question is saying, figure 3.1 shows a truck carrying a load moving horizontally along a flat level road. So we have the load on the truck and also the direction of the motion where the truck is going. Okay, so let's try to lead the question. So question A is saying, the road has a mass of 2,500 kgs. So sometimes in an exam, they're not going to give you mass in kgs. So your job is to convert the mass from grams into kgs. Physics or science representation. So if you're new to this channel, subscribe and share this video to your friends if you find it useful. So the question is saying figure 3.1 shows a truck carrying a load moving horizontally along a flat level road. So we have a truck here and also the direction of the motion where the truck is going. And also it is carrying a load at the back. Now the question is saying the load has a mass of 2,500 kgs. So we can collect the data here, where we are going to say the mass it is 2,500 kgs. Now, one thing that you need to know is that mass is measured in kilograms or kgs. So in an exam, if they give you the mass in grams, you need to convert into kgs. So the question is saying, calculate the weight of the load. The gravitational force on unit mass, G, is 10 Newton per kgs. So we also have the gravity, which is G, which is equal to 10 Newtons per kgs. Now they are asking us to calculate the weight of the load. So what is very, very important here is you knowing the formula for calculating the weight of an object. So the weight of an object is given by mass multiplied by gravity, which is G. So here we have the mass of the load, which is 2,500 kgs. So it's very, very important when you're doing the calculations, you need also to include the units. Then the gravity, it is 10 newtons per kgs. Then when I multiply, I'm going to get 25,000. Now, usually the weight is measured in newtons. So I'm going to say 25,000 newtons. So here they have already put it as the newtons. So there is no need of us indicating the newtons here. That is very, very important to know. Then apart from that one, we have also Roman numeral number 2, which is saying, draw an arrow on figure 3.1 to show the weight of the load. So knowing that, by definition, weight is just the action due to gravity that acts on an object. Now usually the gravity acts downward. It acts downward on an object. So when you throw something up, it always comes down, meaning the action due to gravity acts downward. So for us indicating the weight of this load here, we are just going to indicate something. So we can say the weight is going to be represented by this arrow here. Then at the end, we are going to mention this one as the weight. So we need to write the weight. So that is how we represent the weight of an object. Now apart from that one, the force which is going to be acted upwards here, this one we are going to call it as the normal force because this load here is at rest. That is also one thing that we need to know. Roman numeral number 3 is saying, the load on the truck is made of solid gold. The volume of the load is 1.3 multiplied by 10 to the power 5 centimeters cubic. So we can say the volume of this solid gold is 1.3 multiplied by 10 to the power 5 centimeters cubic. Then apart from this one here, we also have the mass of this solid gold, which is 2,500 kgs. Okay. Now the question is saying, calculate the density of the gold. Calculate the density of gold in kgs per meters cubic. Now the question is saying we need to calculate the density of gold in kilograms per meters cubic. Now, as you can see here, the mass is in kilograms or kgs. But the only thing which is not in meters cubic it is this one here, which is the volume. So the volume is in centimeters cubic. So there is a need for us to convert this one here into meters cubic. Now, we can say this 1.3 multiplied by 10 to the power 5 is same as 30,000. So 130,000 centimeters cubic is same as this one here. We are going to say multiply by, so here we are going to have 1 meter cubic divided by 1 million. So always what you need to know here is that 1 meter cubic is always equivalent to 1 million centimeters cubic. That is one thing that you need to know. So centimeters cubic and centimeters cubic, they are going to cancel each other. Then here we have 4 zeros. So if I cancel 4 zeros here, even here I'm going to cancel 4 zeros. Then from there I'm going to say 13 multiplied by 1 meter cubic. I'm going to have 13 meter cubic divided by 10. So when I divide here, I'm going to get 0.13 meter cubic. So this one is our volume that we are going to use now to calculate the density of the God, of the solid God or God. Okay, so let's try to calculate the density. We are going to say density is going to be equal to mass over volume. So the mass that we have here, it is 2,500 kgs. So we have 2,500 kgs. Then divided by the volume, which is 0.13 meters cubic. Then when I divide, the density is going to be equal to 19,230.8. Then at the end we are going to put kilograms per meter cubic. So this answer I've just rounded off to 1 decimal place. So that is our answer for the density of the God. Okay, so let's try to answer the next one. So the next one is saying figure 3.2 shows the speed time graph for the motion of the truck on a journey. So the first one, it is saying state the maximum speed of the truck on this journey. So the maximum speed of this truck is at this point, A, I guess at this point. That is when we are going to find the maximum. So now at this point here, we are going to see that this one is, so this one is going to be 12 meters per second. Okay, so that is how they are counting the numbers. See, two lines, two small lines, they are representing 1. So it's like when you move from 10, you need to count two small lines so that you have 11. Then also 2 small lines so that you have 12. Number 2, state the time taken by the truck to reach the maximum speed. So the time taken for the truck to reach the maximum speed, it is at this point here, where we are going to have 100 seconds. So we are going to say, we are going to have 100 seconds. So they have already put it as the units here. So there is no need for us to put the units. If you are new to this channel, subscribe for more videos like this. Thanks for watching.